Today we will learn a skill that will prepare us for looking at our third type of reaction that we will be studying in this chapter, and that is an oxidation reduction reaction. So our job today is to learn to determine oxidation numbers or oxidation states. An oxidation number or oxidation state refers to the charge an atom would have in a molecule or ionic compound if electrons were transferred completely. Okay, so what we're learning really is a bookkeeping tool, and this can be slightly confusing because in ionic compounds, electrons are transferred completely to whatever they're getting bonded with. But in a covalent compound, electrons are being shared. But most of the time, they are not being shared equally. There's one element that's going to keep the electrons around it more than the other element. And so that kind of helps to get your head around what this oxidation number really means. But you guys, it's a bookkeeping tool. That's what it is. It's kind of imaginary. It's not in ionic compounds, but in covalent it is. Okay. Some atoms are rigid, and they have only one oxidation state, which is the same as their ionic charge. For instance, sodium. Sodium, if it's in a compound, sodium is always positive 1, the same as its ionic charge. But there are other non-metals, generally, that are more flexible, having numerous oxidation states. Nitrogen has 6 different oxidation states. Okay, so the skill we're going to learn today is actually really easy. The idea behind what we're doing and what does oxidation state actually mean, that part is a little more abstract, that with more experience with these reactions, we'll get. So this is some background, but let's not get lost in this. Let's just stay focused on the skill we're going to learn today, which is determining oxidation number. Determining oxidation number is actually an easy and fun thing to do. So we have to follow a set of rules when we're determining oxidation numbers. Kind of like if you're doing a Sudoku puzzle. You have to follow a set of rules in terms of what number you could put in a box. Okay, it's the same with oxidation number. There are guidelines and there are rules, and we follow them to figure out this puzzle. It's a puzzle. It's fun. Okay, so the first thing to keep in mind is that the oxidation state of an atom in an element is always 0. Meaning, if it is elemental, for instance, a piece of sodium metal, or, right, so this says sodium solid, so that's a piece of sodium metal, or oxygen gas, okay, these are elements that are on their own. They're not sharing electrons or transferring electrons to anyone. We assume that they have all of their own electrons. They haven't given any away, they haven't accepted any, they're not sharing any. So the oxidation state of any pure element is always 0. The oxidation state of a monatomic ion is always the same as its ionic charge. So, if sodium is a +1 ion, that means that in a compound, sodium always has an oxidation state of +1, the same as its ionic charge. Monatomic, made up of just one atom, okay? Chloride ion has an oxidation state of -1. So ionic charges, oxidation states are identical for monatomic. In a compound, number 3, fluorine always has an oxidation state of -1. So fluorine is one of these it's a rigid nonmetal. Its oxidation state never varies. Its oxidation state is always -1. We aren't asking why. Okay, we can talk about why later in the year, but we're not asking why right now. We're learning the rules and learning how to do this. Hydrogen is also one of these things that is not flexible. Hydrogen, in a compound, hydrogen always has an oxidation state of +1. Last but not least, we have oxygen. In a compound, notice, in a compound, oxygen is always -2, except for peroxide, which is -1. All right, and these things are very important because they can guide us into assigning oxidation states to elements that aren't so rigid, that are more flexible in terms of their oxidation state. Okay, we've got a couple of rules we must live by. The first rule is the sum of oxidation states of the atoms that are in a compound must be 0. And for an ion, and we'll do an example of one, the sum of the oxidation states must equal the charge on the ion. All right, so these are our rules that we must follow in assigning oxidation states. We have a set of guidelines that will guide us into determining known and unknown oxidation states. So let's go for it. Let's do this. Let's assign some oxidation states to some compounds. We will begin with carbon dioxide. So here it is, CO2, carbon dioxide. So we want to figure out in this molecule what is the oxidation state of carbon and what is the oxidation state of oxygen. Okay, so I've got carbon, I've got oxygen, and I'm just going to put this over here. This is the sum. This is not dollars, okay? And you'll see what this means in a moment. All right. So if I look at these two elements, carbon, I have nothing to guide me, but if I look back at my guidelines, I know that oxygen, when it's in a compound, always has the same oxidation state. And that oxidation state is -2. So I know that. So I'm going to say -2 because I know that that's the oxidation state of oxygen in a compound. And how many of them do I have in the compound? Actually, it would probably make more sense if I actually did this. I've got 2 of them. So overall, in terms of oxidation state coming from the oxygen, I've got a -4. Okay, this carbon dioxide is a neutral compound. So my sum has to equal 0. What number plus -4 equals 0? positive 4. So that is the oxidation state of carbon. So we would say that carbon in carbon dioxide has an oxidation state of positive 4, and oxygen has an oxidation state of negative 2. So carbon is positive 4, oxygen negative 2. Let's do another one. Let's do sulfur. Let's do another one. Sulfur hexafluoride. So, sulfur we don't have a rule for sulfur, but we have a rule for fluoride. So the rule for fluoride is that in a compound, fluoride always has an oxidation state of negative 1. And how many of them do we have? We have 6. So we have a total of negative 6. This is a neutral compound, so our sum has to be 0. What number plus negative 6 is 0? Positive 6. So that means that in this compound, sulfur has an oxidation state of positive 6. Fluoride has an oxidation state of negative 1. Okay. How about nitrate ion? So we're going to find the oxidation states of all the atoms in this nitrate ion. So we have nitrogen. We have, in this case, 3 oxygens. Going to leave that sum there. Okay, we have a rule for oxygen, so we're going to start with oxygen. In a compound, oxygen always has an oxidation state of negative 2, and we have 3 of them. So we have an overall negative 6. Now, this is not an electrically neutral compound. This compound has a charge. What is the charge on this ion? Negative 1. So that means that our sum has to total negative 1. So what number plus negative 6 gives us a sum of negative 1? That's going to be positive 5. So in nitrate, nitrogen has an oxidation state of positive 5. And as always, oxygen has an oxidation state of negative 2 in this compound. And that is that.